Hello, this is Jennifer Martinez. In this video, we're going to analyze revolutions. In this particular example, we're going to analyze the revolution of a disk drive. And it says here, a constant angular velocity disk drive spins a disk at a constant speed. What is angular velocity? Angular velocity measures how fast is the angle changing with respect to time, sometimes known as angular speed. This is different than the kind of speed we usually are talking about when we talk about miles per hour. So if you're traveling 60 miles per hour, that would be how fast is your distance changing with respect to time. Sometimes they call that linear speed or linear velocity. But what we're looking at here is angular velocity, which is how fast the angle is changing with respect to time. So let's move on. Suppose a disk makes 480 revolutions per minute. So what does this mean? That means that each minute you're going to revolve around 480 times. So I'm just going to write it like this, per 1 minute. How many degrees will a point on the edge of the disk move in 2 seconds? So, what are we going to do? Let's get this first in revolutions per second. So we know we can change the units here to minutes and seconds. So we know that there happens to be 60 seconds in a minute. This cancels out minutes, and it puts us at 8 revolutions per second. I got that by canceling the zeros, and 6 goes into 48 8 times. We're just taking 480 divided by 60. We get revolutions per second. So this is how many revolutions it's doing per second, which is a little bit easier to visualize than per minute, isn't it? 480 per minute. I can't visualize as well as 8 revolutions every second. Okay, but the question says through how many degrees. So we know, since there is 360 degrees equals 1 revolution, we could change revolutions into degrees. So I'm going to put a revolution here and degrees up here. And what do we know? We know 360 degrees equals 1 revolution. So if I multiply this by 360, you get 2,880 degrees per second. The revolutions cancels, so we end up with degrees per second. So we're almost there. Through how many degrees will a point on the edge of the disk move in 2 seconds? Well, they want to know, if it said 1 second, that would be the answer. So they want 2 seconds. So I'm just going to take that and multiply that by 2. Multiply by 2, you get 5,760. And the explanation here, here's the rate, how many degrees per second, and I'm going to cancel that. So this is the angular velocity per second. Now it's in degrees. We're going to find a better measurement than degrees in the future to have for angular velocity, but in the meantime, that's how we can find how many degrees a point will move in so many seconds. So analyzing this, we have a disk drive that's spinning like a record. It's going very fast. It's going 8 revolutions around every second. So in 2 seconds, this is how many degrees. And realize that is, if it's 8 revolutions in 1 second, that means 16 revolutions around in 2 seconds will give you that many degrees. Okay, so let's look at this next one. A pulley rotates 115 degrees in 1 minute. So you have this huge pulley and it's probably going around this circular object. How many rotations does the pulley make in 1 hour? So I'm going to start with 115 degrees per minute. What does that mean? That means 115 degrees in 1 minute. And I am going to figure out, we want to know rotations, and we're in degrees. So I'm going to go from degrees to rotations. And rotations is very similar to revolutions. It's the same thing. 360 degrees is 1 revolution or 1 rotation. So I'm going to put 360 here and 1 there. So I'm going to divide by 360. Might as well do this all at the same time, so that we'll get rid of the degrees, because they want to know not how many rotations does it do per minute, but per hour. So I'm going to multiply this by one more thing. I want to get rid of minutes. So minutes is in the denominator here, so I'm going to put it in the numerator, put hours in the denominator, and we know that there's 60 minutes in 1 hour. So if I take this and I multiply it by 60 and then divide by 360, I can use my calculator, or I can cancel these. 60 goes into 360 6 times. So if I do that, I get 19.16666. Goes on forever. So it's approximately, if I round to the nearest whole number, about 19 rotations or revolutions per hour. So that's what it asks. How many rotations does a pulley make in 1 hour? So the answer is 19. That seems like a lot slower than our other example, our first example. The pulley's going pretty slow. 150 degrees is something that's less than 180, all in an hour. Hope that helps.